Hello everyone, my name is Jesse Herrera. This is my Cap 1 assignment, ATP pathways, about glucose and fatty acids. I have my very amateur drawing here, but it just shows the 4 steps from that it takes from glucose to become ATP, where we can get our energy from. It also shows where the fatty acids will jump in at, right between that stage 2 and 3, where they will come in from the acetyl CoA into the citric acid cycle. The glycosis takes place in the cytosol of the cell, so it won't be in the mitochondria. In glycosis, the glucose is converted to the pyruvate. It's a cycle that it's a process that will be taking place twice. That's why the glucose will be split into 2 pyruvate, which will make for an overall 4 ATP and 2 NADH. Overall, the glycosis converts 1 6-carbon molecule of glucose into 2 3-carbon molecules of pyruvate. In the pyruvate oxidation, which is the next step, each pyruvate from glucose goes into the mitochondrial matrix. So there it is converted into 2-carbon molecule with the coenzyme A. This is known as the acetyl CoA. Carbon dioxide is released at this point, and NADH is generated. Then the next step will be moving on to the citric acid cycle. Here the acetyl CoA that was made combines with the 4-carbon molecule and goes through a cycle of reactions, finally regenerating the 4-carbon starting molecule. ATP, NADH, and FADH2 are provided, and carbon dioxide is released. Finally, we now go to the final stage, the oxidative phosphorylation. The NADH and FADH2 deposit their electrons in the electron transport chain, which you can see the chain there, which turn back into NAD plus and FAD. When the electrons move down the chain, the energy is released and used to pump the proteins out of the matrix. Proteins flow back into the matrix through the enzyme called ATP synthesis, which then makes into ATP. So that's where we get our energy from to do all the exercising, just daily things through life where we don't feel tired. We need energy to keep moving. The fatty acids, as I put here, they go through their own process called beta oxidation, which takes place in the matrix of the mitochondria. In beta oxidation, the fatty acids are broken down into a series of 2 carbon units combined with with the coenzyme A, which forms the acetyl CoA. That's where the acetyl CoA then feeds into the citric acid cycle. That's where the fatty acids will jump in. That's the basic breakdown of the 2 pathways. The glucose pathway will yield 34 ATP. The net is actually 32 because we had to use 2 to start off with. For the fatty acids, there's a total of 460 ATP. 1 molecule of glycerol, it provides 19 of that 460, and then 3 molecules of the 18 carbon fatty acids yields the other 441 for a total of 460. As far as what factors influence ATP production, how we exercise influences that. How hard we exercise, the intensity, the duration, and our fitness level. Fitness levels will make a difference. Somebody who's new to working out versus somebody who's been working out and exercising for years, the ATP will be produced at different levels, and how fast it'll be produced for each person is a little different. Some of the implications for exercising with intensity and duration from ATP, as far as like intensity, the higher the intensity of the anaerobic systems will be used. At the low intensities, the aerobic systems are used. So the higher the intensity, more glycogen will be used from ATP. The only reason it becomes a glycogen because it replenishes faster than the fatty ATP that's produced from the fatty acids. But if you're looking for total duration where you need long levels of energy, the fatty acids will produce more energy. For the duration exercising, that's where what we learned in this week in our weekly videos, the creatine phosphate system is used for the longer exercise. From our weekly videos this week, it's called the energy reservoir. This is where the body needs to go dig down deep for long duration exercises because the ATP is out. What I mean by that is the glycogen will be depleted. If you're doing interval training, the glycogen is depleted about 45 to 90 minutes in. If you're doing anaerobic exercising, it's depleted about 30 to 45 minutes in. So it needs to produce more. And once those are depleted, actually, the protein in the body will start to increase its level of contribution to ATP and energy needs, because that's where the body needs to draw from once the glycogen is empty. Hope you enjoyed my presentation. Thank you.